Hello guys and welcome. May I officially welcome you to Heat and Temperature. Yes, I said heat and temperature. Contrary to what you've always thought, heat and temperature are two different concepts in physics, even though they may be related. In fact, they are different because even their SI units are different. While heat is a form of energy measured in joules, temperature can be measured in different units depending on the scale we even choose. Three popular temperature units are available for us to choose. These are the Kelvin, the degree Celsius, and the degree Fahrenheit. Now, we are usually more conversant with the word temperature because we can easily feel it. You can tell when the weather is, say, hot or cold. You can even tell if an object is hot or cold by just touching it. On the other hand, heat is a word we mostly associate with hot objects like, say, fire or even the sun. In fact, heat is a form of energy which can be transferred from one object to another or converted from one form of energy to the other. Now, how about we define what heat and temperature actually is in physics? Now, let's start with temperature. First, you need to remember that every form or state in which matter is made up of what? Very tiny particles, which we said are molecules. Again, these molecules actually possess kinetic energy. So we can define temperature as a measure of the average kinetic energy of these molecules in the object. Now, in simple language, we can even define temperature as the degree of hotness or coldness of an object. While heat, as we said, is a form of energy, can be defined as the total kinetic energy of the molecules in an object. So, we have just defined temperature as a measure of the average kinetic energy and heat energy as the total kinetic energy of the molecules in an object. But what does these two statements actually mean? And how are they even different? Let us illustrate. Assuming, say, we have an object and there are 5 molecules in the object. And let's say these molecules have kinetic energies of 1 joule, 2 joules, 3 joules, 4 joules, and 5 joules. The heat energy of this object, which we earlier said is the total kinetic energy of these molecules, will be what? 1 plus 2 plus 3 plus 4 plus 5 joules, right? This is going to give us a total of 15 joules. Now, what about the temperature? All we need to do is to find the average kinetic energy, and that is going to give us an indication of the temperature. But the average is the sum of the energies divided by how many molecules we have. This will be 15 over 5, which is going to give us 3 joules. Now, remember that the average kinetic energy is an indication of the temperature and not exactly the temperature. So, we cannot say that the temperature is exactly 3 joules, but that this value, which is 3 joules, represents what? The temperature. Now, depending on the scale which we choose to use for temperature. So, if a thermometer is placed on this object, it will read a certain value. Now, we can assume that the temperature at this value, or the average kinetic energy, for example, is, say, 27 degrees Celsius. But note that different temperature scales will give us different values for this same value of average kinetic energy, which is 3 joules. Let's assume, say, I add 1 more molecule to the 5 which we already have, and that the kinetic energy of this new molecule which I am adding is, say, 3 joules. Now, what do you think will be the heat energy of this object? Yes, this will now be our initial total kinetic energy, which was what? 15 joules plus 3 joules, which is now what? 18 joules. But check this out. The temperature, which is what? An indication of the average kinetic energy, will now be 18 joules over 6, right? This is still equal to 3 joules, same as the average kinetic energy as we had earlier, indicating that the temperature is still the same. So, we can now say that the heat energy of an object depends on the number of molecules, but the temperature may not. So what have we learned today? We have learned that heat is the total kinetic energy of the molecules of an object, while temperature is a measure of the average kinetic energy of the molecules. I hope I've been able to introduce enough heat in you to raise your temperature and provide you with enough energy to make you face today's challenges. How about we do more in the next lesson? See you guys then.